Na, goes.
Hello everyone and welcome back to my channel. Today's video will be about a journey that started back in 2021. Back then I started learning about Minecraft Spigot plugins, and after 1v1t closed, I put my learned knowledge into use by making my own Anarchy server called Nanarchy. But Nanarchy eventually shut down as well, because of the lack of a proper server host. But while making plugins for Nanarchy, I learned a lot about the Minecraft protocol. In case you don't know, the Minecraft protocol defines exactly how data should be communicated from client to server and vice versa. Many libraries and tools implement the Minecraft protocol in order to make either a Minecraft client or a Minecraft server. For example, Mindflayer, the library I used to make my Hypixel bot. I was also trying to learn Rust at the time, so I tried in many attempts to create a Minecraft server using Rust and my knowledge of the Minecraft protocol. But my attempts failed miserably because the project was too ambitious for a programming language I barely knew. In February of this year, I found my failed projects in my Rust folder. That inspired me to try to make a Minecraft server again, but this time using Java, a programming language that I know very well. Not after long, I managed to create a server that is able to answer server pings properly. After the basics were done, I had to implement the packets that handle the player login. I skipped the whole authentication part, so that the server is basically in offline mode. It took a long time for me to figure out why players were stuck on the loading terrain screen, but I eventually found a workaround that actually works. After that, I started working on loading chunks to the player. It took a lot of trial and error, but I eventually figured it out. While developing all of this, I got an idea. Making a whole Minecraft server from scratch with chunks, entities, player interaction, storage containers, day and night cycle, and whatever else is part of the vanilla gameplay would be far too much for me to do by myself, and there are already projects that do exactly that. So my idea was to make a Minecraft server that I can use to Rickroll people. The plan was to create a canvas using item frames that are modified using the map data packet. By continuously updating the item frames, it is possible to create a video. I started by making my own video file type called MCMV, short for Minecraft map video format, that tells the server exactly what part of the maps changes how and when. Then I implemented this file type by writing a MP4 to MCMV converter in the C programming language for efficiency. But even when using C, it took roughly an hour to convert the 3-minute video to the MCMV file format. The problem was that each color of a pixel in the video needs to be converted to one of the 207 predefined colors, at least for the Minecraft versions 1.12 and above. I later made it more efficient, but it still took 40 minutes to convert. What I didn't know at the time was that I tried to solve a commonly known problem called color quantization, but I didn't bother to optimize it later on, because the video needs to be converted only once anyways. After that, I had to support the MCMV file type on the server side of things, by reading it and writing the maps according to the data. And again, after some trial and error, I got it finished surprisingly quick. But there was another problem. Because the video had a relatively high resolution, and with that, I mean 720p, the total amount of data transmitted was over 3 GB. I tried to implement the regular compression defined in the Minecraft protocol, but after trying to get it right, I failed to do so. At this point, I had to put this project to a hold, because I had the Abitur, the German final exams. After I got back to the project 2 months later, I had a new perspective on the code I wrote, and I realized that the packet code I wrote had a lot of bugs in it. So I would need to change it from the ground up in order to implement packet compression defined in the Minecraft protocol. So instead of the regular packet compression, I decided to make another compression that I planned using in the first place. The compression I envisioned is simple. Each item frame gets divided into chunks. If the amount of changed pixels in this chunk exceeds a certain threshold, the chunk will be sent, otherwise it will not. In order to lower the amount of rectangular areas that are being sent to the client, I also had to write an algorithm that groups the updated chunks together. The problem was that the time for calculating these groups was getting exponentially larger as the frame gets divided into more chunks when using a simple brute force technique. I searched very long for a fast algorithm that could do that, but the only algorithms I found were either very hard to understand or very bad greedy algorithms. So I made my own greedy algorithm that was relatively fast, and my testing showed that it was pretty accurate as well. While trying the implementation of my algorithm, I got a lot of visual glitches again. But in the end, it all worked out, and I finally finished the video. The only thing left was the audio. I could have used note blocks to make the music, but I didn't want to edit the notes manually. So I simply made a resource pack that contains the audio file and made it so you have to download it in order to join the server. This is actually even better than just playing note blocks. I hope you enjoyed this video and see you in the next one.